All right, 6.5 volumes. We're going to do this for 3 days. All right, so let's kind of recall integral. Let's say that we have this shape. This is, let's make it x. And this is f of x. Let's say that we want to figure out what this area is. And then let's say that we have from A to B. Okay, how do we figure out what the area is in that shaded region? That should be pretty easy, right? Okay, so the area is equal to what? The area is equal to what? Yeah, integral a to b of f of x dx, right? Easy. Okay, you've been doing that for like 2 chapters, so you kind of remember this. Okay, so now we are going to, so area is a 2D thing, right? You know, just how, like the surface area. We are now going to go 1 dimension more. We're going to go to volume, so it's now 3D. Okay, so let's talk about volume. Volume is the same thing as area, the way we're thinking about it. So remember that area came from Riemann's sum. Riemann's sum says if we can figure out how long or what the area is of that one, we could add up all of these very, very, very small areas, and then eventually it becomes a big area. Okay, so what we're going to do now is we are going to do the same thing with volume. Okay, volume is 3D, so let's think about it a little bit. I have some props, I think. Let's see. So let's say that I have this thing, which is 2D, right? This is pretty much 2D. The thickness is almost negligible, this index card. So I'm going to take this thing and I'm going to stack it, right? So I have one and then stack another one, and eventually I stack a whole stack. Now I have volume. Does that make sense? So I take a small surface area, and if I keep stacking it up, then I create volume. And you can do that with anything, right? So if you have a cylinder, you can stack circles all the way up until it becomes a cylinder, right? So that is one way to do this. You take a small thing and you add it all up, and it becomes a volume. That's one way. The other way is if you have something like this. Let's say that this is a shape you want. And you have this axis that you want to revolve over, and then so you open it up, and then you create volume.
So this is the project?
No. Okay, so that's that one. Or like this is a half circle, right? This half circle is a 2D area. We're going to revolve it around this axis, and then that creates volume. Yes? Okay, so we're going to focus on these 2 methods. Actually, there's another method, but actually 2 more methods. But anyways, today we're just going to focus on these. So
take half a cross section and multiply by 2 pi.
Good. Later. Okay, so we're going to take a small surface area, and then we're going to integrate. That way we add up all the numbers. And then the other one is we're going to take a like a cross section like this, and then we're going to rotate it so it becomes a 3D shape. Oh, sorry. 3D shape. All right. Okay. Let's solve some problems. Okay, so we are going to do the disk method today. The disk method. Okay, so the WSQ I had you guys answer, the question was, what axis is the integration perpendicular to? It is perpendicular to x-axis, according to that question, because the way they had it drawn was something like this. No, the other way around. Something like this. So they are adding up all of these little slices along the x-axis. So it's always perpendicular to wherever you're going. Okay, so that is the axis. Okay, so let's look at this one first. The region bounded by the graph y equals square root x, and the x-axis between 0 and 1 is rotated about the x-axis. The first thing you want to do is just draw a picture. Y equals square root x, and the x-axis between 0 and 1 is this part. We are going to rotate it around the x-axis. If you guys need a wake-up candy, just in case, just pass it around. All right, we're going to rotate it around the x-axis. So what's going to happen is you're going to think this is rotating, right? So it becomes kind of like a cone. Can you guys imagine that? You're just rotating around, so it's kind of like a cone. All right, so maybe it would be better if I show you this prop. So it's like this. You know, let's think this is the x-axis. We're going to rotate it around the axis and then try to figure out what this volume is. Okay, this volume has to do with this radius, right? This is basically, how should I do this? If I rotate it around, I can think of it as a lot of different areas added up in this direction, right? Are you guys with me? Okay. So what we're going to do is think about, so this is the final shape. The final shape kind of looks like a cone. We are going to slice this cone. We're going to slice this cone this way. And then that's going to create a little slice. And then we're going to add up all the slices along. Okay, so let's take a look at one of the slices. You guys can imagine things pretty well, right, spatially. I'm going to turn this cone this way and look at the slice. You guys can see that? Okay, the question is, what is this radius? How long is that radius?
1.
The height of y at 1.
The height of y at 1, which is, let's say, square root x. Which is 1, right? Yes, which is 1. Now, it's going to keep getting shorter and shorter as it goes, right? Right? So let's just look at that radius as is, which is square root x. We're not going to think about it as 1. It is 1, but it's going to change. So let's just put square root x. What is the 2D surface area of this circle? What is the area of this circle? Right, pi r squared, right? So that is pi x. Right? The surface is just pi x. We're now going to integrate along the x-axis and then take all that surface area and add it all up. You guys with me? So volume then is the integral of pi r squared, which in this case r is square root x, so this is pi x. dx. dx because we're moving along the x-axis, okay? Later on, we're going to move along the y-axis, so it's going to be different. Okay, from where to where, though? We're not going to integrate forever. 0 to 1. All right, so now let's go ahead and solve this. So this is pi, always take out the constant, so pi from 0 to 1 x dx. So that is pi x squared over 2 evaluated from 0 to 1. So that is pi over 2. So this shape has a volume of pi over 2. All right, so what you want to do is first, you always want to draw a picture and then figure out what the radius is, and then the area, and then the volume. Okay, so let's try another one. Find the volume of the solid obtained by rotating the region bounded by y equals x plus 1, y equals 0, x and equals 0, and x equals 2 about the x-axis. Okay, so please don't write everything down, just write the important parts. Okay, so what I want you to do is draw a picture, color in the surface area, revolve it around whatever the axis is, and then like draw a semi-3D shape. Okay, x plus 1 looks like this, y equals 0 is this one, x equals 0 is here, x equals 2 is here, so this area is this one here. We are going to rotate it around the x-axis. So we're going to go like that. So this is the shape, kind of like a speakerphone or something. All right, so what we want to do is figure out what r is. So what is r? Good, x plus 1. So then what is the area? Pi r squared. Pi, and then what is r? Yeah, x plus 1 squared. Okay, we're going to have to integrate, which means that we should multiply this out. Okay, actually this one is okay not to multiply out if you know how to kind of do u sub, a very easy u sub in your head. Okay, volume is going to be the integral of the area along the x-axis. So whenever they tell you which axis you're turning, that is the axis you're integrating with. So this is dx from where to where? 0 to 2. All right, go ahead and figure out the volume. All right, the answer is 26 pi over 3. Okay, if you didn't get that number right, you just integrated wrong. So you may, if u sub is not, just intuitive to you at this point, it's okay. Just multiply this whole thing out. You can just integrate one term at a time. It's a little longer, but it's, doable. Let's try another one. Find the volume of the solid obtained by rotating the region. Again, please just write down the essential parts. This graph, these 3 limits, and about the x-axis. Okay, so let's talk about this a little bit because some of you got stuck on the integration. Okay, so r is equal to e to the x. So area is pi r squared, which is pi e to the x squared, which is pi times e to the 2x. Okay, so when you have an exponent 2 and an exponent, and then you multiply. Okay, so volume is equal to the integral from -1 to 1 of pi e to the 2x dx. Okay, when we're integrating e to the x, people always forget it's just that same function itself. We just have to guess. Okay, so e to the 2x is probably the function, which is e to the 2x times 2. So some of you forgot that too, which means you need to get rid of it by multiplying 1/2. So this is pi times 1/2 e to the 2x integrated from -1 to 1. Okay, so I'm not going to substitute. I'm just going to tell you the answer. The answer is, depending on how you simplified it, pi over 2 times e squared minus e to the -2. All right. Give me a thumbs up if this is good. You pretty much know what to do. And sideways, need a little practice. Downwards, I don't know what's going on still. Okay. All right. Okay, so let's try another one. This time we're gonna go around the y-axis. Okay, so this thing that was this way, we were integrating with the x-axis. We're gonna go this way. We're gonna integrate y-axis. Okay, we're gonna flip it over y-axis. Okay, find the volume of the solid obtained by rotating the region bounded by 2x equals y squared. X equals 0, y equals 4, and around the y-axis. Okay, so write down just the essential information, which is just all of those boundaries. Next, always draw a picture. 2x equals y squared. That means x is equal to y squared over 2. X equals is always a sideways parabola, right? So it's a sideways parabola, so x equals 1/2 y squared. That is a sideways parabola with a compress of 1/2. That's just like this. X equals 0.
Well, it shouldn't be like wider.
Wider?
Like, instead of.
Let me think. When y is 1, x is 1/2.
Because it's increasing.
Oh, yeah, you're right. Yes. X equals 0, y equals 4 around the y-axis. Shade what you think we should integrate. Shade the surface area. This is y equals 4. Shade the surface area that we are going to rotate around the y-axis. Okay, hopefully you all shaded in the right part, which is this part. We are going to, because it says it's bounded by those 3 lines. This is the only part that's bounded by those 3 lines. So we're going to turn it around the y-axis, which means it's going to look like this. All right. Now we're going around the y-axis, so it's going to be a little different. What is R? So remember, my slice is not along the x-axis anymore. My slice is this way, right? So R is this length. So how long is R?
Y squared over 2.
Y squared over 2, right? And then kind of think about previous sections. When we are integrating along the y, we go from the right to left, this way. Okay? Okay, so R is equal to 1/2 y squared. Thank you. Okay, so this way, R is 1/2 y squared. So area is still pi r squared. So that is pi 1/2 y squared squared. So that is pi times 1/4 y to the 4th. Okay, volume. Which axis are we going to integrate to? Y. Okay, so it's going to be dy. That means all your limits have to be y's. Okay, so y from where to where?
0 to 4.
Very good, 0 to 4. Okay, pi 1/4 y to the 4th dy. Please make sure it's dy. We are rotating around the y-axis. Okay, so try it. Let me know when you have the answer. All right, answer is 256/5 pi. Okay. Okay, let's try another one. We're not going to go about the y-axis. Let's go about any axis. Okay, let's try this one. I'm just going to write it out so you can see it. Some of you in the back is pretty small. Y equals x cubed. Y equals 1, x equals 0. We're going to rotate around y equals 1. Okay, draw a picture. Okay, y equals x cubed is this one. Oh, that's not good. Y equals 1 is this one. X equals 0 is this one. So the region that's bounded is this one. We're going to rotate around y equals 1. So this is my new axis. It's not x-axis, not y-axis. It's actually another line, which is okay. We're going to rotate around here. So this is the shape I want. Okay, now let's look at the slice. It's this little thing here, right? So if you look at it here, there is a radius, or the radius like that. Maybe you'll look at it here. What is this radius? This is the tricky part. What is the radius?
1 minus x cubed.
Is it?
1 minus x cubed.
Did I do it wrong? Right. 1 minus x cubed. Sorry. I was looking at the part I rotate. Yes. So you're looking from top down. So remember, we're finding the area. And when we have an area that's enclosed between two curves, that's going to be the top one minus the bottom one. So the radius is 1 minus x cubed. 1 minus x cubed. Okay, so A is going to be pi r squared. Volume, integral of pi r squared. What axis are we integrating with? Dx. Okay, even though it says y equals 1, we are going in the x direction, okay? So please be careful. From where to where?
0 to 1.
0 to 1. Now, if you are not sure what this point is, you will have to figure out. So basically plug in 1 equals y and then figure out x if it's not visible. But this one is pretty easy. So go ahead and integrate this. Okay, this is one of those questions that you don't want to use du dx. You should multiply this out. Okay, so be easier to do. 1 minus 2x cubed plus x to the 6 and then dx. Okay, the answer is 9/14 pi.